So the domain model last time, here's the answer. So we the classes are customer, movie video, member who is a special customer because he can make reservations of videos while a regular customer cannot. And customer can provide reviews for movie videos and can also buy or rent. So he has a buys association with the association class to the movie video class with this quantity attribute. So the reason you have this association class is because you want to put an attribute on it. And you have this rent association, not with the movie video, but with the rental copy. So why do we have the rental copy here? It's because you need to keep track of which copy is rented out. Say you have a movie video with 5 copies. Each one may be rented to a different customer. So you need to have a unique serial number on each copy. Then you need to know which copy a particular customer rents. While if you buy a video, you don't keep track of the copies. Every copy is the same. You just buy it. You just sell it out, right? So that's why you need this rental copy class here. Well, not a say buy copy or sell copy. So similarly, member reserves rental copy, not directly a movie video, because the reservation is for a particular copy. And so the multiplicities are member can reserve 0 to 5 rental copies. And each rental copy may be reserved by 1 or 0 members, right? It can be reserved by 0 members because no one is reserving it, but it cannot be reserved for more than 2 members at the same time. At any one time, it can only be reserved by 1 member. So a movie video has 0 to or star rental copies. That is, if a video is rented out, then it has no copies. Review. So review here, we put it as a separate class with 2 associations. One is to movie video, one is to customer. While buys is an association class with the customer movie video association. So in fact, you can put review as a separate association class. Instead of instead of a review with 2 associations, you can have 1 association between movie video and customer, and put review as the association class for that association. Both are okay. Similarly, buys, you can also put it as a separate class and have 2 associations, one from movie video and one from customer. So it's getting cluttered. So let me. So these 2 styles, one is they have an association class. One is to have a separate class with 2 associations. In this case, both are okay. But in general, having an association class is more restrictive and more precise. So here it says there's always an association between movie video and the customer, and the buys describes that association. Well, here it says review has an association with movie video, it's 4. Another association with the customer, but these 2 may not correspond to the same pair of movie video and customer, right? It's a more loose less restrictive description. While having association class describes that there's got to be a pair of movie video and customer for which the bias association class is describing. So if you can always use the association class where it's suitable, but for some other relationships which are not precisely described as association classes, then perhaps a third class like this one is more appropriate. So this is the solution after adding all the attributes. So these attributes are identified from the problem statement. So member has a member number and password, etc. So and now this second solution adds a new association between customer and rental copy called rental history. Because current rental only keeps track of the currently rented videos, but it loses track of all the history information. So you may want to keep track of the history for statistics purposes, right? Some videos are rented very often. You buy more copies for put it in the store. Some are rarely rented. Then perhaps you remove it. So it's useful. So you must add a new association because these are two different things. So you cannot simply add attributes. And here you don't need an association class for rental history because you have no attributes. If you added it, it'll be a waste. So this is the solution with the attributes added. So each rental copy has a copy number and a due date. So that's all you need for the rental history. So imagine a customer rented 10 videos in the past 2 months. Each one has a copy number and the date due on it. Then the rental history is just a collection of these rental copy records, right? You don't need a separate attributes in the rental history class. So that's why you just put a rental history name of the association without association class. So only if you need to add additional attributes, then you add association class like this one. Bias, you need a quantity on it. So that's why you need to add a separate bias class. Otherwise, you just name the association bias and without association class. Of course, usually a customer buys one video, right? But if a customer happens to buy more than one video, then you need to keep track of the quantity. If the problem statement says a customer always buys only one copy of a video, never more than one, then perhaps you don't need the bias association class. So common errors representing the client organization. The video shop is the client. So you never place the client into the domain model. So one exception is when perhaps the video shop is a chain store with many different locations all across Hong Kong. Then perhaps you need to have a shop in the domain model to represent which location it is. But it is not true for this problem statement. So you don't have to place the video shop into the domain model. Representing the information not specified in the problem statement. So video catalog and bank account, they're never mentioned. So you don't add information unless you feel is necessary and you discuss with the clients. Incorrect overuse of generalization. So non-member is a common mistake. So in the class diagram, you have a inheritance, a generalization relationship. A member is a special customer, but if you add a non-member to the inheritance hierarchy, say this is a non-member, then it'll be empty, right? There's no new attributes of a non-member beyond what is already in the customer. So it'll be a useless subclass. Only if you want to add new attributes or operations, you add a new subclass. So incorrect overuse of aggregation and composition. Movie video, rental copy, that's association, not composition or aggregation. Review, movie video, customer, and member, that's generalization. So when in doubt, always use association. It's never wrong, because aggregation and composition are special type of associations. So if you replace aggregation or composition with association, it's never wrong. It's just less precise. So in this example, there's no aggregation or compositions. So remember, the difference between aggregation and composition is that the composition is stronger. This part cannot exist independent of the whole, while aggregation is weaker. The part can exist independent of the whole. So if you have an open shape here, it's aggregation. If you have a black filled shape here, it's composition. Representing operations. So generates, browses videos, enters information, looks up information. These should not be in the domain model because they belong to the use case model. That is, they describe dynamic operations that are not persistent in the database. So the customer rents a video copy, rental copy. That is part of the domain model because you need to save this association between a customer and the rental copy into the database. But a customer browses the video listing. That is not part of the domain model because it's a transient operation. When he browses it, he's done, it's gone. It's not stored in the database. So you should make a distinction between operations that are transient and operations that are persistent. Representing implementation aspects. So system, web, telephone, reports, keyboard, printers, these should never be put into the domain model. Over-specifying the model. So many students put the staff manager into the domain model. The question is, do we need to keep information about these things? If not, then we do not need to put them into the domain model. It's really problem specific. So in this particular example, you're trying to keep track of the videos and the customer rental history and buying history. So the staff and manager are really not important. That is, who enters the information into the system, who takes care of the transaction of renting a video or selling a video, is not really important. So we decide to not specify them in the domain model. Perhaps if you're developing a payroll system for the video shop, then obviously you need these classes. but for the management of the operations, they're not important. Perhaps you can argue that they are important. Perhaps you need to keep track of who did which transaction to trace responsibility. Then perhaps it's useful. So it's really a judgment you can make. For this answer we give, we think they're not important. But in other cases, they may be important. So you need to negotiate with the client to delimit the scope of the domain model. So the key question when designing the domain model is what information about procedures, things, need to be persistent, to be stored in a database. Right? If it's an operation, transient operation, that does not need to be saved in the database, then you do not put it into the domain model. So any questions on this example? Okay, good. So we move on to use case modeling. So the use case modeling consists of these steps: find actors and use cases, and structure the use case model, and detail the use cases. So we'll describe the first one first. So the use case modeling captures the system behavior from the user's point of view. That is, what the user can do with the system. Described in cooperation with the domain model, because the domain model provides the vocabulary, the basis on which you develop the use case model. Helps capturing data and functional requirements, planning iterations of development. In the early iterations, you focus on the most important use cases, and in the later iterations, you move on to the secondary use cases. Validating the system, that is developing acceptance tests. So if a use case is a student registers for courses, then you should design acceptance tests to test that use case. Can the student register for courses or not? So at the validation of the development effort. So the dynamic model gets started with use case analysis. Dynamic model refers to the use case model, analysis model, and design models later in the development stage. So they are opposed to the static model, which is the domain model, describing the database. Dynamic model describes the operation. Use cases drive the entire development effort. Remember the 4+1 view of the unified process, where use cases sit in the middle, and then you have 4 views. One is the analysis and design and implementation and deployment. So it drives the entire development effort, because essentially when you refine your system from high level of abstraction to a more detailed level, you always it's based on use cases. So you should establish traceability from use cases to the more detailed models and back. So use case model is developed incrementally. That is, you focus on the most important ones and gradually add less detailed ones, and also fill in the details of the use cases. So all required functionalities are described in the use cases. That is, it serves as part of the contract. If it's not described in the use case model, then you do not have to implement it. So actors represent something outside the system that interacts directly with it. So it is represented as a stick figure. So just always draw the actor as this figure. Don't try to be artistic and add new details. Always have this circle and sticks. That's enough. So the actor can be a person or another system, provides input to or takes output from the system. So you do not need to describe in detail of the actors because they are outside of the system. They provide input to or take output from a role a user can play. So you can have multiple roles per user and multiple users per role. For example, me as a person, I can play a role of a professor of a course, or I can play the role of advisor to my PG students, right? As the same user, I can play multiple roles. Therefore, there are multiple actors for the same user. Multiple users per role, that's also possible. So actors are usually the source for discovering the use cases. You start from the actors, and you think about what the actors can do. And each thing he can do is listed as a use case. So actor is a stereotype of a UML class. So this thing here looks like a stick figure, right? But it's actually a class. So the standard class notation is this, right? You have a three compartment with the name, attributes, and operations. So the actor is just exactly a class. You just use this notation as a stereotype to denote that it's a very special class. So therefore, it's a stereotype of a UML class. It's a classifier, similar to the distinction between classes and objects. Then you have the distinction between actors and a user or system, a specific user or system. It's an instance. So if the actor is a student, then each one of you is an instance of the actor. So how do you identify actors? So you think about who can or what can use the system, what role do they play in the interaction, who gets to provide information to the system, and what other systems interact with this system. For the registration system, it interacts with the billing system. So the billing system is an actor when you're designing the registration system. Similarly, the registration system is an actor if you're designing the billing system, depending on which one you're trying to develop. Does anything happen at a fixed time? If so, then time can be an actor. So if something is triggered periodically, say every month, then you can place time, the clock, as the actor. Who installs, starts, and shuts down or maintains the system. So this who here could be an actor, could be the IT staff, right? So it's common to have both a domain model class and an actor that represent the same thing. So if the system needs to store information, the data about an actor, so a student is a domain model class in the registration system because you need to keep track of the student's ID, age, and grades, and etc. At the same time, it's an actor because a student, as a human being, he sits at a computer and uses the system. He's external to the system, right? So as an actor, the student is outside of the system. He's a living, breathing human being. but the domain class is inside of the system because the system needs to keep track of all the data related to the student. Time can be an actor, and as that if something is triggered periodically. So input-output devices are never actors because they represent a way of providing input and output, which is a decision not made until design time, or implementation time. So, for example, keyboards, printers are never actors. For each actor, we briefly describe the role it plays when interacting with the system. So we'll see example next. So this is our familiar registration system. So this is the problem statement you saw before. Now we need to identify the actors. Obviously, students is the one actor to select for course offerings for the coming semester. So professors are another actor, right? Billing system is an actor. So this is perhaps harder to find. So the registration system sends information to the billing system so the student can be billed for the semester. Therefore, the billing system is something outside of the registration system that receives information from the registration system. So it is an actor. So the actor does not have to be a human, even though it's drawn with a stick figure. It can be an external system. So now we have identified three actors: student, professor, and billing system. And you add a brief description besides the actors. Say student is a person who is registered to take classes at the university. Professor is a person who is part of the teaching staff of the university. So this brief description. And the use case model is essentially a box representing the system we're trying to develop, course registration system, and three actors with lines connecting it to the system. So this is a use case model so far. We haven't identified the specific use cases yet, so we'll do that next. So a use case looks like this in a novel. It's another stereotype representing a special class. It's a specific way of using the system by performing some part of its functionality. So it describes the interaction that takes place between an actor and the system, and what the system must do, considered from the actor's point of view. So constitutes a complete sequence of events and actions initiated by an actor. So this sequence of events will be described as the detailed description of the use case. We'll discuss this in more detail next lecture. So right now we're trying to identify the use cases themselves, not their details yet. Initially, we're only concerned with the normal sequence of events and actions and ignore alternative events actions. So the normal sequence, the usual sequence, is also called the sunny day scenario. That is, everything goes smoothly, everything goes right, nothing wrong happens. The alternative event actions represent the exceptions. So when something goes wrong, how do you handle that? just like in regular programming, when you write your Java program, for example, you always write the mainline code first, and then add exception handlers later, right? So a use case is a stereotype of a UML class, and as with the class object distinction, now you have a use case and scenario distinction. So a use case is a classifier, a scenario is an instance. So registering for a course, say it's a use case, then a specific student registering for a specific course at Tuesday, October 5th, that is the scenario. So it's you can have many concrete scenarios for one abstract use case. A scenario is a concrete, focused, informal description of a single use of the system from the viewpoint of a single actor. So it is an actual attempt to carry out a use case. So it is something that happens at a specific point in time, at a specific location. It's concrete. So there are two viewpoints of use case modeling. That is, you top down or bottom up. Top down is when you start with use cases and refine with scenarios. Bottom up is when you start with scenarios and abstract into use cases. In reality, use case specifier, the person who is responsible for the use cases, uses both viewpoints. Perhaps you start from, say, interviewing the users or doing the work yourself to see what actually are the scenarios happening in the real world. Then you abstract the use cases, and then perhaps you refine, and by adding more scenarios when you discuss with the users even more. So it's always both approaches are used in real life. So how do you identify use cases and scenarios? So you ask yourself, what are the tasks that an actor wants the system to perform? So register for a course, it's obviously a task you want to do with the registration system, right? What information does an actor access, including create, store, change, remove, and add, read in the system? What external changes does an actor need to inform the system about? So that's the part of the input to the system to inform of the change in the environment. What events does an actor need to be informed about by the system? That's the output from the system to the actor. So, for example, the registration system provides information about registered students to the billing system. So that's the event output to the billing system. So how will the system be supported and maintained? So perhaps besides regular use cases, you need to add a maintenance use case by the IT staff. If that's important to do. For this case, we think the maintenance is perhaps a secondary use case. We don't put it into the use case design first. So state a use case name from the perspective of the user at the present tense. That is, someone does something, not someone is doing or someone did something. So verb phrase in active voice, right? Someone does something, not something is done by somebody. So provides a description of the purpose of the use case and the outline of its functionality. So not a detailed description like the step-by-step description, that's later. Now it's an abstract, simple description. use application domain terms in descriptions, which means that use the terms from the domain model. If you design the domain model to have a professor, then use the word professor, don't use the word instructor. So that's why you have the domain model as the common data dictionary for your later development. Everyone uses the same terminology to avoid confusion. So here's the ASU example. We identify use cases by finding out all the operations that system can perform. So at the beginning of the semester, students may request a course catalog containing a list of course offerings needed for the semester. So someone prepares course catalog. Information about each course are included to help students make informed decisions. So it's information like instructor, department, prerequisites. These are part of the course catalog. So there's no new functionality here. So the new system will allow students to here students make informed decisions. This is not part of the use case model because it's a mental process of the student. So it's not something the student uses the registration system to do, right? It's something that happens in his head. So we do not put it as part of the use case. The new system will allow students to select 4 course offerings for the coming semester. So students select course offering. That is a functionality. In addition, each student will indicate 2 alternative courses in case the course offering becomes filled or is canceled. So here is indicating alternative choices. It's essentially the same as select course offering, except you select primary or secondary or alternative choices. So it's not a new functionality. It's part of the select course offering functionality. So no course offering will have more than 40 students or fewer than 10 students. So this is a domain model requirement. We add these 40 and 10 as the multiplicity specification in the domain model. So we don't have any new functionality here. A course offering with fewer than 10 students will be canceled. So this is the functionality. Someone cancels the course offering. So fewer than 10 students, this will be discussed later as the precondition of the operation. So once the registration process is completed for a student, the registration system sends information to the billing system so students can be billed for the semester. So someone prepare billing information for the billing system. So remember, the actor is always something outside of the system you're developing. So someone prepare billing information. So this someone here will identify it later. So professors must be able to access the online system to indicate which courses they will be teaching and to see which students sign up for their course offerings. So students select courses to teach, and professors select courses to teach. Professor requests enrollment list. So to see which students sign up for their course offerings. So you write this more formal statement that request enrollment list. So you don't have to translate word by word from the problem statement into the functionality. You can change the words if it's more precise. For each semester, there's a period of time that students can change their schedule. So students change course offering. So there's a period of time. It's another precondition we'll specify as part of the details, not at the top level. So students must be able to access the system during this time to add and drop courses. Student add and drop course offering. So these are the new functionalities. Access the system is not a new functionality. It's implicit in everything you do with the system. So now we have identified the functionalities performed by each actor, say register. We have students, billing system, and professor. Now in the functionalities we have someone. So someone prepares the course catalog. Someone manages the course offerings, etc. So now we add a new actor, which is not explicit in the problem statement, but we add it after analyzing all the functionalities. So a registrar is a person who is responsible for maintaining the curriculum information and prepare the course catalog, etc. So now we have all the actors and their functionalities. So we have registrar has 2 functionalities, students has 4, professor has 2. Someone here we haven't identified yet. So who prepares billing information for the billing system? So we'll discuss that later. So what is a good use case? A use case represents a major piece of information, a piece of functionality that is complete from beginning to end. It must deliver something of value to an actor. So we identified 4 functionalities for the student actor: select, add, drop, change, course offering. So you can draw each one as a use case, but is this a good design or not? The question to ask is, what is the actor trying to accomplish? Why is he selecting a course offering? He's selecting it because he wants to add it, right? So select course offering is not really an independent piece of functionality that is complete from beginning to end. It's part of the functionality of registering for a course. So what is the actor trying to accomplish? He's trying to register for courses. And in the process of registering for courses, he can do one of these 4. Add, drop, change, all as part of his action of registering for courses. So we design it as a single use case, register for courses, which includes 4 functionalities: add, drop, change, and select. These are pieces of functionalities, while register for courses is this major piece of functionality that is complete from beginning to end. So we make it more coarse-grained instead of the fine-grained. So a use case represents a major piece of functionality. So it's generally better to have longer and more extensive use cases than smaller ones. So we want complete and real use cases, not several sub-cases. But at the same time, you shouldn't group unrelated functionalities into a single use case. A use case should be cohesive. That is, it should be one thing that the user wants. At the same time, it should be coarse-grained. That is, it should be complete thing that the user wants. So looking at this example, we can identify prepare course catalog, cancel course offering. These, should they be grouped into a single use case? No, because they're very different from each other. They're not part of a single functionality. Then these four, they are really part of a single functionality. So register for courses. That's a single use case we identify. At the same time, the change course offering operation can be accomplished by the add and drop. So we delete that operation. So someone prepares billing information. That's a unique use case. Professor select courses to teach, and professor request enrollment list. So these two, again, are two very different operations. You should not place them into a single use case. You should have two use cases. So now the use case model looks like this. Student registers for courses. Professor select courses to teach, request enrollment list. Register, maintain course information, prepare course catalog. Then we add two more use cases, maintain student information and maintain professor information. So this is the additional use cases we identify after discussing with the client. So these are not explicit in the problem statement. So now we identify a new actor, time, for the prepare billing information. Remember, there's a someone prepares billing information we never identified. Now we add an actor, time, because you should prepare billing information at the end of the add drop period, right? It is triggered by a time, by clock. So it is not triggered by some other actor's action. So time is the actor that triggers the use case, and the billing system is the actor that receives information from the registration system. So notice the direction of the arrow here. From time, you trigger this, and from the billing system, you send information to the from the registration system, send information to the billing system. So the arrows are optional, but they can make things more clear. If an arrow is pointing from an actor to a use case, that means that the actor is initiating the action. If an arrow is pointing from the use case to the actor, it means that the actor is receiving information passively from the use case. So remember, all these are classes. So these may look funny to you, but these are really classes. The whole thing is a class diagram. So these are just associations between classes, these arrows. So there's an implicit stereotype that says communication at this edge between the billing system and the registration system. So it's implicit. We don't put this communication stereotype explicitly on it. You can put it on it, it wouldn't be wrong, but we can omit it. So we have identified the use cases. Now we like to so initially we just gave a brief description of the purpose of a use case and outline of the steps required to perform the use case. Later, these steps are refined and described in more detail as we discover more about the functionality required. So we add this so-called flow of events after we design the use cases. That is, add or drop primary courses, add or drop alternative courses, and each one may have a list of steps. So that's what we mean by refine the steps and describe in more detail later. So right now we're just giving a brief description of the purpose. So so here's another example for the use case modeling. You saw this last time. So identify the actors and group the functionality into use cases and show the use cases and their related actors in the use case diagram. So we first analyze the requirements. We are only interested in these functional requirements that provide something of value for some actor. So what are the something of value for some actor? So keep track of which movie videos have been bought and rented and by whom. So functionalities include someone buys a video, someone rents a video, videos bought, the system must record the quantity bought. Videos rented, the system must record which copy of the video has been rented and when it's due back. So no new functionality here. This is mainly domain model information as attributes to the domain model. System must keep track of overdue rental videos and send email notices to customers who have videos overdue. So here, customer receive an overdue notice. So this is the arrow pointing from the use case to the actor, signaling information sent from the system to the actor. Video shop have a customer membership option. So someone enters member information. So the discount information, the member will receive 10% discount on video sales and rentals. It's a non-functional requirement that affects the operation of some use cases, such as buying and selling videos. So it's a non-functional requirement, which means that itself is not a piece of functionality. It is something that modifies an existing piece of functionality. So something that you can add on top of buying and selling videos. It's not a piece of functionality itself. So members should be able to make reservations for movie video rentals. So member reserve a video. So staff reserve a video. So you can infer these two functionalities because if it's done via the web, then its member reserves the video. If it's done at the store, then the staff does it from the system's perspective. So how the reservation is done is not important from the functionality perspective. So you just need to say reserve a video. You don't specify the by telephone or via the web as part of the functionality. A member can reserve at most 5 movie videos at any one time. There's no limit as to how many videos a member or non-member can rent at any one time. So this is a non-functional requirement that is at most 5. That's part of the domain model, not part of the use case. Video shop should allow customers to input mini reviews. So customer enters a review. Reviews should be anonymous if the customer so wishes. So this is the elaboration of the preceding functional requirement. Not a separate functionality. Video shop maintains the following information. So this is the staff enter update customer information. So the requirement is stated implicitly that someone has to enter the customer member information into the system. Someone here is not explicit. You should infer that it is staff from domain knowledge or from common sense. It also supersedes the requirements regarding someone entering member information. So we had a requirement earlier that someone enters member information. So because a member is just a special customer, if you have here a staff enters updates customer information, you don't need the previous one. In addition, members are assigned a membership number by the video shop, which allows them to access the members-only area of the video shop's website, including accessing and changing their personal information. So member update personal information. So that is functionality. So this is a special functionality for the members. A customer, regular customer who is not a member, cannot do this. The staff must update the information for a regular customer, but the member can choose to do it himself. Using the web, a customer should be able to buy and rent videos. So buy a video, rent a video, browse reviews. So here, this is part of the use case. All three are part of the use case. But if you recall, buy and rent are also put into the domain model because they are persistent. You should save this information in the database, but browse the video reviews is transient. It's not part of the database. Managers must be able to generate various reports on sales, rentals of videos. So manager generates reports. That is the functionality. Again, this is part of the use case, not the domain model. You never put generating reports into the domain model. Staff must be able to buy, sell, rent videos. So staff sell a video. So this is really, if you think about it, it's the same functionality as a customer buys a video. It's just from two perspectives. So we can view it as the same functionality, put it into the same use case later. Staff rent a video. Here, he's not renting it himself, he's renting it to a customer. Staff return a rented video. Again, this is done by the customer and staff collaboratively. When selling or renting videos, staff must be able to look up customer information. So look up customer information. That is a use case, a functionality. Staff must be able to enter the basic information. So enter video information. That is a functionality. So we have identified many functionalities. Now we need to group them into use cases by making them more coarse-grained. So now we have these actors: customer, member who is a special type of customer, staff, and manager who is a special type of staff. So a member is special because in addition to what a customer can do, a member can use the system to reserve videos and access and change their personal information via the web. So a manager is special because in addition to what staff can do, a manager can also generate various reports on sales and rentals of videos. So how many times a video is rented for the past year, and so on. So now we have all these actors and their functionalities. We group them into use cases. We place these three into a single use case. Customer buy a video, staff sell a video, staff look up customer information in order to sell the video. So this is part of the buy video use case specified from the customer's perspective. Then rental. Rent video consists of customer rent a video, customer receive overdue notice, staff rent a video, staff return a rented video, staff look up customer information. So notice that look up customer information is a functionality that is used in both the buy video and rent video use cases. Manage reviews, customer enter and browse reviews. Reserve videos, so member or staff can both take part in the reserve video use case. Staff enter update customer information. In addition, member can update his own information, manage customer info, and generate reports and enter video information. These are separate use cases. So now we have identified the use cases. Solution is this. Customer takes part in three use cases: buy, rent, and manage reviews. A member takes part in buy, rent, manage reviews. In addition, he can also reserve video and manage customer information. A staff can do buy video, rent video, reserve video, manage customer information, and manage video information. A manager can do all of these things except manage reviews. So here's the use case diagram, but we can actually simplify it by taking advantage of generalization. So if you recall, all of these are classes. They're just funny-looking classes. These are stereotyped classes. So therefore, anything you can do with class diagram, you can do with these things. So if you use generalization, you can realize that a member is a special customer, so you put a generalization relationship between customer and member. And a manager is a special staff, therefore you put a generalization relationship here. So if you recall, these are just associations between classes. And anything that any association the superclass takes part in is also implicitly true for the subclasses. Therefore, if you have customer by video association here, you implicitly have an association between the member and by video, because member is the subclass of customer. So you can omit that association from the diagram. So as a result, by having these inheritance relationships, you can make the diagram simpler and remove many of the associations from the subclasses. How about putting these two as a single use case and call it buy/rent video? Well, that could be possible, but if you think about it, buy video and rent video are really pretty separate functionalities. So it's a good idea to separate them into two use cases. Oftentimes, you can have choices as to how coarse-grained you want to make your use cases. You can make judgments based on your particular application. So there's often not a single right answer. So this is the diagram. Then you place a short description for each use case besides the diagram. So buy video allows the customer via the web or a staff in the shop to select a video and its quantity for purchase, and staff to look up customer member information. So in combination, this is a complete. This is a use case model. So what are the common errors you make in doing the use case modeling? Do not represent input-output devices as actors, like a web, telephone, etc. They represent how something is done. But we are trying to identify what is done, not how. So too large use cases, so like maintain video database. You may want to place the customer information and the video information into a single use case, such as maintain database. But these two are really pretty separate, right? You should keep them separate. Two small use cases, so do not represent each operation as a use case. Try to group related functionalities or operations into more coarse-grained use cases. At the same time, keep each use case focused on a particular functionality. Don't be too coarse-grained. Reuse the same functionality for different actors. This is the what you should do, not an error. So this, for example, buy video. For example, here, buy video is pointed to by both the customer and the staff. So a common error is to draw two use cases. One is the buy video linked with the customer. One is the sell video linked to the staff. But you should really have one because it's the same action. It's just viewed from different perspectives. So give meaningful names to the use cases. Don't be afraid to use longer names. Do not represent non-functional requirements like 10% discount. Only represent the functional part requirements. That is what needs to be done. So these are really modifiers on top of the functional requirements. Login functionality is not a use case from the user's perspective. It is a non-functional security requirement that can be represented by an administration use case. So implicitly, everyone must log in to the system to do anything with the system. So it is really a pervasive security requirement, not part of the user's use case. Perhaps if you have another actor called administrator, then perhaps he can manage the login functionality by specifying exactly what the login procedure is. But from the user's perspective, it is something that he has to do in order to accomplish what he wants to do. It's not what he wants to do per se, right? So at the use case specifier, we are trying to identify what the user is trying to accomplish. So we only place the functionality that add value to the user. That is, register for a course, delete a course, add a course, Logging is just something that is not part of the user functionality. So it's not a structured chart, it's not a domain model, and it's not a work of art. So this is when students draw the charts in a different format, or some students draw this elaborate person as an actor instead of having the stick figure. So use case detailed specification. We have identified the high-level use cases. Now we need to specify the details inside of each use case. So it includes use case name in the present tense, verb phrase, brief description of what it does, participating actors, precondition, flow of events, that is a step-by-step description of what you need to do for the use case, post-conditions, alternative flows, that is exception handling. If something wrong happens, what do? And special non-functional requirements, including, say, the 10% discount or security or response time requirements. So a precondition is a statement about the state or condition the system must be in order for the use case to be performed. So it may be omitted if the system state is not important to how the use case starts. Post conditions are written so that the use case descriptions are as independent of each other as possible to specify what should be true, not how it's made true. So I think we'll have examples next. So preconditions are necessary but not sufficient for the use case to be performed. So starting a use case always requires an actor to do something. So when you have an arrow pointing from the actor to the use case, it means that the actor is initiating the use case. So the student is initiating the action of registering for courses. There may be a precondition that says the student must not have any outstanding balance on his account as a necessary precondition for registering for courses use case. But the use case itself is always initiated by the student himself, while the precondition just serves as a guard to prevent something from happening, but they're never the active initiators. The students' actors are the active initiators. So flow of events, I think we'll discuss this in the next lecture. It's a pretty large piece of thing to discuss. Okay, any questions? Okay, see you next time.